Recording in progress.
Hello and welcome. I am Dr. Pauline Fu. In this video, I will go over some questions about hypothesis test. So first, I will solve questions. Why can't I move the computer? What you want? All right. So this question is section 1.8, page 41. Using question 1.43, using table 2, let T0 be a particular value of T. Use table to find T0 values such that the following statements are true. So A, probability of T greater equal to T0 equal to 0.025, degree of freedom is 10. Okay, so we go to the T table. This is normal table. The T table is here. So this is the T table. First, we found degree of freedom is 10. Okay. So try to use a pencil. So first, locate degree of freedom 10. And then locate 0.05. So this is 0.05 here. Okay, and the intersection part is T0, so 0.05, this column, okay, this column down, okay, let me double check. And then intersection part of degree of freedom with this number. So this is the answer, 2.228, okay, you can see here. Okay, so that is question 1. Alternatively, you can use Excel function. In Excel, you type in equal. Try to find my Excel. Okay, I will show you the formula here. You can try it in Excel. In Excel, you write down equal, and then you type in T dot INV. T dot INV means find critical value. And then you are asked to enter the probability. So you type in 0.975. How do I get 0.975? You use 1 minus this number, 0.025, because Excel is based on area to the left of the point. So then comma, and then type in the degree of freedom 10, closing bracket. And you will get from Excel, it is 2.228. This is from Excel, the same result as we get from the table. Okay, so now I will explain why it is 0.075. When you use the table, see the table, this alpha is based on area to the right of this T value. But Excel is based on area to the left. This is the Excel based on area to the left. When you are given this alpha 0.025, table is based on T value to the right, but Excel based on this area. And we know the total area on the bell-shaped curve is 1. So this area must be 1 minus 0.025. Okay, so equal to 0.975. Okay, 0.975 is this area. So let's go back to the module. Let's do the second question. Okay, B, do question B. So again, two methods. One, using the table. Two, using Excel. Okay, so when I use table, I need to locate degree of freedom 5, and then I need to locate 0.01. The intersection part is T0. So let's go to the table. So in the table, I will erase found degree of freedom 5, degree of freedom 5, and then found 0.01. This is 0.01. Okay, so the intersection part of 5 with 0.01, this one is the answer, 3.365. Okay, so go back. So 3.365 is the answer, 3.365. By the way, the first one, question A, the answer is 2.228. Okay, so that is the table method. And now for B, how do you use Excel? In Excel, you type in equal, and then T dot INV, inverse means critical value, and then use 1 minus 0.01, that is 0.99, comma, degree of freedom is 5, and you will get 3.365. Okay, so this is this question. So now next question. 1.58, that is on page 1.58. It is on page 50. Okay, this question. Right. So this is the page number, page 50, section 1.9. Walking to improve health. In a study investigating a link between walking and improved health, researchers reported that adults walked an average of 5.5 days in the past month for the purpose of health or recreation. Suppose you want to determine if the true average number of days in the past month that adults walked for the purpose of health or recreation is longer than 5.5 days. Okay. So question A, identify the parameter of interest. The parameter of the interest. The parameter of the interest is the average number of days in the past months that adults worked. Okay, that is the parameter. Now, average number of days. Okay. And the question B, specify the null and alternative hypothesis. Okay. When you state the null hypothesis, we use H0. Alternative, we use H1. Okay, and the statement said the number of days is lower than, and this keyword lower apply to H1 perspective. So you write down H1 first, mu, smaller than 5.5. Okay, and H0 is opposite of H1. So when mu is when H1 is smaller than, so H0 is greater or equal to 5.5, greater equal to 5.5. Okay. So this is question B. Question C. Describe type 1 error in words of a problem. Okay. Type 1 error means the null hypothesis is correct, but you reject the null hypothesis. Okay, so that means you are saying the mean average is smaller than 5.5, when in fact it is greater or equal to 5.5. That is type 1 error. Okay, so question D, describe a type 2 error. Type 2 error means when H0 is false, you does not reject H0. That is type 2 error. Okay. So in this situation, when the average, you state the mean is greater or equal to 5.5, when in fact it is smaller than 5.5. So that is type 2 error. Okay. And to help you understand type 1 error and type 2 errors, I usually has a table. Okay, try to see if I can draw a table. Do I have space here? No. Don't. So anyway, what is the type 1 error? When H0 is true, you reject H0. That is type 1 error. What is type 2 error? Type 2 error is when H0 is false. You do not reject H0. Okay. So this is this question. Next question. I will do this one. It is still session 1.9. It is on page 51. Page 51. Question 1.62. Question 1.62. Tipping points in daily deal transactions. It is from Journal of Interactive Marketing. Study of a tipping point for ventures purchased at try to find this at daily deal sites in Korea. After determining the tipping point of a daily deal, the researchers wanted to know the mean number of ventures sold 30 minutes before and 30 minutes after the deal was activated. Summary statistics on the number of ventures for 2 time periods are shown in this table. So basically it is before and after. Okay, so it is before and after. So this is this one is after. Okay, this one is after. So for each sample size, you have sample size for before 2211, sample size for after 2617, mean number of ventures before 4.73, after 14.26, the standard deviation for before 27.58, for after 110.71. Okay, so that is the question, the given condition. Question A, is there evidence to conclude that the true mean number of ventures sold 30 minutes 30 minutes before the tipping point is less than 5, test the claim at 0.1 level of significance. So this is this question. So how do we do the test? Usually we follow 5 steps. Step 1, we make state a non-alternative hypothesis. So in this case, I'm going to write down H0 here. So H0 is the null hypothesis. H1 is alternative hypothesis. Because the keyword less than 5, so I write down H1 first, mu smaller than 5. And H0 is the opposite of H1, so mu greater or equal to 5. Okay, so that is step 1. Step 2, set alpha 0.1. And step 3, calculate the test statistics. Okay, test statistic, we use t-test. So t equal to mean value x bar. In textbook, it also use y bar, doesn't matter. Okay, mean value minus the hypothesized mu 0 over sample standard deviation divide square root of sample size. Okay. So x bar in this case is 4.73. So this is x bar. Textbook also use y bar, the same thing, okay? S, this is S, and sample size N. So you plug in all these things, the mu 0, okay? Mu 0 is 5. Okay, 5 is mu 0. Mu 0 is 5. So you plug in all these 4 numbers, you are going to get a test statistic equal to negative 0.46, negative 0.46. Okay. So once you found these test statistics, you need to compare this test statistic with a critical value. Critical value. How do you find the critical value? You need to based on the table. Okay, so you have a degree of freedom. This actually is a large sample size problem. Large sample size problem. So you can find degree of freedom is this number minus 1. So degree of freedom equal to 2110. And then you have alpha 0.1. And this is the left tail test. Okay, so let's go to the table, T table, found the critical value. T table, found the critical value. So I'm going to erase those annotation. Okay. So first we need to locate 0.1. Okay, so 0.1 is here. Because alpha given is 0.1, 0.1. Okay. And then we locate that degree of freedom, 2210. But the table does not give me 2210. Okay. So if you can use actually a very, well, I didn't present the complete table here. If you go to your textbook, found the T table. I'm trying to find it now. When you have a very big number and when you have 0.1, this is 0.01. So the given number is 0.1. I'm sorry, the given number is 0.1, not 0.01. This is 0.1. Okay, this is 0.1. And then you go down. On your textbook, there is an, after many number here, there is a infinity, means very big number. And then the test statistic would be 1.282. 1.282. Okay, so that means this point is 1.282. But we know in our situation, it is left tail test, and we know t distribution is symmetric. So we have to get critical value here, negative 1.282. That is our critical value. Okay, this is our critical value. And the test statistic we get is a negative 0.46. So our test statistic is here, negative 0.46. Okay, in the lecture module and textbook, it is said critical value decide rejection region. So this is rejection region, this left tail. And now our critical value is not in the rejection region. So do not reject H0. Do not reject H0. Okay, so I go back to module 1 here. The conclusion is do not reject H0 because a test statistic is not in the rejection region. Do not reject H0 means H0 is correct. See, this is our H0 means the mean is greater or equal to 5. The final conclusion, the mean is greater or equal to 5. Okay, so this is a question A. Similarly, you can do question B. Very similar approach. Okay, so this is this question here, hypothesis test. And the next one would be our, try to find page number for, oh, this is page number. It is section 1.10, page 63. Okay, how do I make this font bigger? I have to erase this one. I'm using my mark, not the weakness. Page 63. Question 1.69. Okay. So basically, you are comparing two population means. Okay, you can read this from textbook. Okay, so you are given group 1 and group 2. Okay, the sample size is so the data is a mismatch. So this is group 1 data here. Group 1 data is here. Okay, and group 2 data is here. Okay, group 2 data is here. So group 1 has, try to adjust the size. Group 1 sample size is 26. Group 2 sample size 26. Group 1 mean is 28.6. Group 2 mean 24.9. Group 1 standard deviation 12.5. Group 2 standard deviation 12.2. Okay. So what is the question here? the question is compare the mean total ratings for two groups at 0.5. There's an extra. This is extra. Okay, I should delete it. At 0.05 level of significance. 0.05 level of significance. Okay. So basically, you are comparing two population means. Okay, two population means. Okay, now it is better. So you can see the complete result, complete description. Okay. Again, you follow 5 steps approach. Step 1, you state the null and alternative hypothesis. Okay. The null hypothesis said population 1 mean equal to population 2 mean. Okay, so mu1 equal to mu2. Those populations are the same. That is H0, null hypothesis. And H1, alternative hypothesis. Quickly read over the, do we have keyword and argument favor? We can go presented with. So it's just compare the mean group, the mean for two populations. So alternative is mu1 not equal to mu2. Okay. Step 2, alpha is given 0.05. Step 3, calculate test statistics. Okay. To calculate test statistics, first, you need to calculate pooled variance, SP square. SP square, pooled variance. Okay. Pooled variance equal to sample 1 size minus 1. Okay. Times sample 1 squared. Okay. I need some space. I will erase those. And then plus sample 2 size minus 1 square times sample 2 standard deviation square, and then over n1 plus n2 minus 2. So 26 is n1. This 26 is n2. You have those. And what is S1? S1 is 12.5. S2, 12.2. So you know every number. So you can calculate SP square. We call pooled variance. And the result of the calculation, 152. 152.55. Okay, 152.55. And once you have this one, and then you calculate test statistic T. Okay, so I'm going to erase something here because I need space to annotate. Okay. Now, test statistic T. Our textbook uses the mean that said this is Y1 bar, this is Y2 bar, 24.9. Most textbooks will use X1 bar, X2 bar. They are the same thing, just different label, okay? So maybe I will stick with our textbook. So test statistic T equal to Y1 bar minus Y2 bar, okay? Over square root of SP square times 1, I have to erase this bar here. SP square times 1 over sample 1 size n1 plus 1 over n2. Okay, so this is test statistic. Plug in Y bar with 28.6, Y2 bar 24.9, N1 26, N2 26, SP square 152.55. Okay, so and the result for this test statistic is 0.18. 0.18 is test statistic. Okay, so now this is step 3, calculate test statistics. Step 4, found the critical value for t. Because this is a two-tailed test, so we need to find t half alpha. Okay, that is critical value, t half alpha. Alpha equal to 0.05, half alpha 0.025, 0.025, okay. Degree of freedom equal to N1 plus N2 minus 2. That is degree of freedom is 50. Okay, so you need to go to the table. Okay, this table here. Okay, found the degree of freedom 50. Okay, in your text, I have 23 maximum here. In your textbook, you have somewhere here. When you have degree of freedom 50, and then locate 0.025, 0.025. This one, this column, I'm pretty sure is 0.025. See, this is 0.025, okay? So the intersection part of 50 and 0.025, actually the textbook does not have 50. So you go, they have 40, they have 40 and 60 here. So textbook has 40 here and have 60 here. So 40, you get 2.021, 2.021, okay. And for 60, you have 2.000, okay. Okay, so you can go either 40 or 60 because there is no big difference. Okay, maybe I will take just 2.002, simple, okay. So go back to module. Because this is two-tailed test, we know you have -2 and +2 as a critical value. So compare the test statistic we get is 1.08. So what critical value decide rejection region. This is rejection region. This is rejection region. And our test statistic is 1.08 is here. 1.08. Okay. So test statistic is not in the rejection region. Thus, do not reject H0. Remember what is H0? H0 said mu1 equal to mu2. So H0 is correct at 0.05 level of significance. Okay, so our final conclusion, at 0.05 level of significance, there is no evidence to show that two population means are different. In other words, the two population means are the same, okay, at 0.05 level of significance. So this is this question. So last question is about, I don't have, oops, go to module 1. Okay. Yeah, that's conclude our review for hypothesis test. In summary, we did some critical values and we go over 5-step test, okay, for one population, and also we did for 2 populations. Hope it is help. This lecture helps. Thank you so much for your time. And now I'm going to stop. Screen broadcasting stop. So where is my Zoom? Okay. All right, so I'm going to, oops, recording, stop recording. No, where is the stop recording button? Recording. Oh. Stop on share screen. Okay. Recording. Excellent. So I'm new using the iPad. Where is the stop recording button? Maybe I'll just click the end button.